500 by 420. We are going to have 1.1904, and that is temperature, which is 1.1 approximately 19. The temperature should be what? Kelvin. That's the unit of temperature, 1.19 Kelvin. Question number 2. The quantity of heat energy required to melt completely 1 kilogram of ice at 30 degrees Celsius is, we are given the latent heat of fusion. That's 3.5 times 10 to the power 5 joule per kilogram. We are also given a value for specific heat capacity of ice to be equal to 2.1 times 10 to the power 5 joule per kilogram per Kelvin. But before we go into that, I want us to look at what do we mean by the latent heat. Is the amount of heat supplied to a unit mass of a body to convert it from its original form to another form. And the formula for that is mass times L. That L is the latent heat of fusion, either at melting point or at boiling point. Let me quickly go into that and let's solve that question. Question says the quantity of heat energy required to melt completely 1 kilogram of ice at 30 degrees Celsius. The quantity of heat in this case will be equal to ml plus mct of ice. What are we talking about? The temperature of the ice is any value above that is below 0 degrees Celsius. 0 degrees Celsius is the value of the cold water, okay, between 0 degrees Celsius to 100 degrees Celsius. That is the temperature of any substances in between the temperature of the cold water or a melted ice, okay, to a particular range of temperature of water. But any value below 0 degrees Celsius, it may be -1, -20 degrees Celsius. That is the temperature of the ice. Okay, and by the time the ice is being melted to water, it will gain more temperature. Okay, so we have ice. The question says, what will be the quantity of energy required to melt completely 1 kilogram, that is the mass of that ice, at 30 degrees Celsius. Okay, so we are going to have it is equal to the mass of the ice is 1. Then we are given the latent heat of fusion of the ice, which is L. Okay, that is L, which is 3.5 times 10 raised to power 5 plus. What about the temperature change? Let's look at that. We are given that is mass, which is 1. Then we are given the specific heat capacity of the ice, which is 2.1 times 10 raised to power 5. 2.1 times 10 raised to power 5. Then the temperature is 30. So we are going to solve the two and add it together. So 1 times 1.5 times 10 plus 1 times 1.2 times 10 to the power 5 times 10. Let's see what will be the value. So in this case, let's quickly resolve this. The first value, let's see what it's going to give us. 1 times 3.5, okay, then times 10. Also, normally this one is supposed to give us 3.5 times 10 to the power 5 plus this one will also give us 1 times 2.5 will still give us 2.5. 2.1 rather. 2.1 times 30. Let's see what will be the value of that. 2.1 times 30 must give us 63. Then times 10 is to the power 5. Okay? We are adding this together. Let's say 3.5 times 10 to the power 5 is 1, 2, 3, 4, 5. Plus 63 times 1, 2, 3, 4, 5. Or if we try to take it back to normal, we have 1, 2, 3, 4, 5. Okay? That's what we are having. Which is equal to, so let's multiply this plus, let's multiply this. And we are adding it together. Okay? So let's now see what will be the value of the first one, which is 3.5 times, that is 100,000. 100,000. We are going to have, that is 350,000 plus the value of 63 times 100,000. In this case, if you look at that, we are going to have 630. Then we are going to have 1, 2, 3, 4. Okay, that will be the value. Then we are adding the two values together. Everything will be equal to 6, 6, 5. Then we have 0, 0, 0. And we can take this one to 1, 2, 3, 4, 5, 6. 6.65 times 10 raised to the power 6. We are looking for the quantity of it, joule. And that's the value for the quantity of it, 6.65. Question number 3. 22,000 joule of heat is required to raise the temperature of 1.5 kg of paraffin from 20 degrees Celsius to 30 degrees Celsius. Calculate the specific heat capacity of paraffin. Specific heat capacity, that's Q, quantity of heat, is equal to MCT. Specific heat capacity of paraffin will be equal to quantity of heat, MT. Once we make C the subject of the formula, we have this. We are given the quantity of heat, which is 22,000. Put it there. 22,000. We are given the mass, 1.5. We are given the temperature range from 20 to 30, which is going to be 30 minus 20. So what we are going to have now will be 22,000, 1.5, that's 10. Okay? 22,000. So let's look what will be the value of 1.5 times 10. Okay? 1.5 times 10 will give us 15. So let's divide everything by 15. We are going to have 22,000. What I have on the board divided by 15. We have 1466.66. And this can be written approximately 1466.67. We are looking for specific heat capacity. What is going to be the unit? Joule per kilogram per Kelvin. Joule per kilogram per Kelvin. That's question number 3. Question number 4. Calculate the amount of heat required to melt 2 kg of ice at 2 degrees Celsius to water at 0 degrees Celsius. We are given the value for the specific heat capacity of ice, which is 2090 joule per kilogram per degree Celsius. We are also given the specific latent heat of fusion of ice, which is equal to 33 kilojoule per kilogram. Let's look at the solution to this question. The amount of heat will be equal to mCT plus ml, because the whole process is from ice to water. The quantity of heat to change from the quantity of the heat that is acting on it when it is ice level is this, to water is this. So the total heat that we activate on that body will be mCT plus ml, which is equal to, we are given the mass, which is 2 kg. We are given the C of ice, which is 2090. 2090 times 10 raised to power, that's 2090 joule kilogram per Kelvin. We are not having, that's all. Then times the temperature. The temperature we are having there is from 2 degrees Celsius to water at 0 degrees Celsius. That's times 2. Okay? Then we have plus 2. We are given the latent